All right, welcome back to another one. And I'm pretty sure the audio quality in this one is not up to the mark because I'm using built-in mic. Just been too lazy to set it up inside where I'm recording, but I think it's good enough. So in this one, I want to cover something that I've been doing recently a lot. So I've been exploring some ways to manage or experiment machine learning experiment configurations without going insane. And Hydra, I think, is the one that comes closest to being perfect. Again, there is no tool that is perfect. Hydra has its own drawbacks, and the direction in which the team is moving is very specific. And so, of course, there are times that it's not going to be perfect, but I think it's pretty much the best one at this point that I've encountered. Now, I also sort of want to describe what the use case is essentially and show you the pain point before jumping in to why or how to use Hydra. So essentially, I should just set the premise for it in this way. So if you've trained a model before, a deep learning model especially has a lot of hyperparameters. Now, if you want to build a tool which is to be used by other developers or engineers, you provide ways to override some defaults, or maybe you need some arguments that have to be necessarily provided. Those are mandatory by the user. Okay, so imagine in your example you have a trainer and then you have a training script that is based on that trainer. You provide an API like interface where users can use Pythonic commands to build a trainer and sort of do their own thing with that. But then also you want to provide a simple interface that just trains a vanilla network, and then you have to provide those command line arguments to number of epochs, set the model save parameters and things like that. Now just think about how many experiments or how many arguments you have to sort of manage, and then also different ways that they can be overridden. So you have one that can be overridden Pythonic in a Pythonic way. So maybe you are loading them from a YAX file or maybe a YAML file or just a Python data class file. And then you have some arguments that you somehow decide that these belong in command line also, and then you also provide the interface to override them through command line because those are probably more generally overridden commands, right? So, say for example, you won't allow users. Say, let's talk about Detectron or maybe Labs. You won't allow users to edit model parameters in the command line, but you would allow users to sort of edit the number of epochs and things like that. This is just an example, right? I maybe have blabbered on too long, so I'll just show you an example of how what I'm talking about. So let's build a simple trainer, nothing fancy, just a simple trainer, how it would look like, right? So we start with a class trainer. We define the constructor. It's empty, and then this is the meat of the trainer. You define a trainer and then you call fit on it to say run this trainer on a given data set. We'll see how we can edit that, but for now let's just see the meat of the trainer, right? You get the model, you get the data loader, you get the optimizer, and then you run the number of epochs, and then you get each data point from the data loader, and then you simply uh, do the forward pass and calculate the loss, and then you do the backward pass, and then you optimize the weights. That is it, right? Now let's quickly define these functions that we just used so carelessly. So we have the data loader here, we have the model, and then we have the build optimizer. Now you might be thinking, there, this the function is called get data loader, get model, and then build optimizer. Why not get optimizer? It's a bit of a digression, but see, I like to name functions in a way. Exactly in way of what they're doing. So essentially, get data loader and get model might be downloading models from a cloud bucket or maybe uh, GitHub assets that is very popular. But optimizers are not being downloaded. These are being built in, pretty sure, in the library itself, right, through Dodge. So which is why I like to name it this way. Okay. Now the trainer, let's we can define as many arguments we want to be accepted by the constructor, but I'm going to limit myself in doing that. So let's just say I'm going to define dataset, model, and the config. That's it. And this can be a dictionary or a file. We'll see how it's done. Now that is it, right? Everything else, all the configurations and things will be defined by the configuration here. So this is our trainer class. Now let's say we also want users to be able to sort of run this through command lines. This will provide a Pythonic interface. So for example, someone can import trainer and then sort of start doing their own stuff. Like they will create a trainer. Oh, this should be capital T, so that we can create a trainer and then pass in the arguments and then call it trainer dot. I always miss. I don't know why I always miss a sometimes. Okay, fit and that's it. Right. This is a Pythonic way of doing it. But let's say you wanted a way to sort of run this through command line. You would just create this function called train and a bunch of arguments. Maybe we'll see what, and then you set if the this is the current uh, module being executed, just call train, and this should create a vanilla trainer, and it should uh, okay, I should just run this, right? Now I think this is pretty reasonable. There's a lot of ways you can do it, but then this is how this gets really complex over time. So this is very simple, but let me tell you, the minimum viable commands that you need to pass in is a config, right? And then the config is what something that you parse here. So maybe you just create a bunch of argument parsers. So yeah, like arg parse dot parse some command and something else, and then those will be passed in here, and then users can also do this through a config file. It gets really complex. It's the simplest example I can think of. Right? Hydra is meant for like multi-node, multi-device experiments, but this is the simplest example how you can manage um, these things. So essentially, here I want to start using Hydra. So let me just first run this example. I want to essentially make sure that we reach in here, and so let's print out something. Let's print out trainer constructor. Okay, construct pure, and if I run this, I'm pretty sure it will throw an error. No. Okay, okay. Let me just create a virtual environment. Virtual env and oh, okay. I made a typo here, and let's activate this source env bin activate. No, I don't want this to automatically activate. And then let's run this again. If okay, we'll create a trainer and we'll pass in something, some empty strings, and that's it. And okay, 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 trainer constructor. All right. Now let's start with Hydra. This is the point where I want to bring in Hydra. Okay. So essentially, if you click on Get Started, you will have some key features. Let's not really care about that for now. Okay. So simplest example, and by the way, let's install this also. There's going to be need for that. Okay. So here's a basic example. You have a config in YAML file, right? And then how you read it in your application is a simple syntax where you call Hydra main, and this is the wherever you decorate a function using Hydra main, this is assume that this function is the starting point of your application, which is this is a launcher of your application. Just like in Java, the void main is the starting point of your program. That's the main part that the compiler looks for. And here Hydra main is the way Hydra is designed is that you should assume that this is the place where users should interact, right? So that's why a few things are forbidden, like this function cannot return anything if any function has been decorated by Hydra main, because what you want to return with the function that user is interacting with, especially in command line, right? Doesn't make sense. So here you can, by simply doing this, you can read this config file, right? And it turns it into a Pythonic way of interaction. Now, it doesn't seem like it's a very big deal. Like, how is it making my life easier? But then the features it provides, we'll see in a second, does actually. Um, so for example, if you ran this program with the default path, so user has not provided anything, it will just read this and it will print it out, right? As it does. Now you can override any of the values in the config file using the command line, and it is done in a Pythonic way, right? So you can just say db.user equals to root and db.pass equals to 1234, and here you see user and pass has been overridden by this command, right? And the YAML file can contain these files in hierarchy, like one file links to another, like for example here. So it says the defaults is essentially stored in another file. So db is stored in mysql.yaml and things like that. So essentially, here you see you can edit in that way also, in hierarchical way. So essentially what you get now is a command line way to edit the config files that could have been done, like those are constants, right? The file's content won't change, but in through command line, you can edit the config files or override the config files programmatically or on the go, right? So essentially you have now one central place for all the hyperparameters, and then you can override them through Pythonic commands, which is like in the .py files, or also through the command line. So let us see how it's done. Uh, so let us assume that this trainer will get the omega conf. Like, so what we'll do is we'll read it here. So let us read this dictionary here. Now I'm going to hard code everything. So Hydra main version base is none. Okay, let me just import Hydra to go. And then config path is pretty much this, and the config name is it. You just have to write the name of the file, which is default, right? Okay. Now let me just print this out. So this will automatically give you the dictionary. So it will come in config, and then you can just print omega conf to. So uh, from omega conf, I don't know. Let's see. Okay, yeah, right. I was on the right track actually, and we just print that out. So here I have like a bunch of defaults, like random defaults, and I have put them in. Let's say I do this. I divide them to sections, which is args, args, and then hips, which is hyperparameters. There's a bunch of things. I just want to show how complex a model can get, and this is nothing. There can be a lot more hyperparameters than this. So let me run this code again to see if this actually works. Okay, so we here have this config file loaded by Hydra. Okay, right. Now essentially what we can do is we can pass no, let's not print this anymore. We can pass this config into train, and what does a trainer want, right? A trainer might want like um, there should be a requirement that a configuration should have at least these two keys, right? Arguments and hyperparameters. So let's build a simple check just to emulate a real world experience. Let's build a simple check. So here we will, okay, I should have not removed that trainer constructor. And now to build a configuration, let me just say self.config Or instead of that, let me just do self.args and self.hips equals to self.build config, and I'll pass the config that I get, right? Okay, and now let me just copy this helper function here so that you get the idea of what's happening. So it accepts a YAML file name. No, this is a simplified version. So it will just accept a dict conf, right? So it's the dict config, and by default it's going to be none, and returns args and hips namespace essentially. So we don't want this. We will return config.train or config.args or config.hips, and if any of those keys are not contained, we will just throw an error message that those keys are missing. So this is like a simple check, right? Now let me just print in this way. I don't know, let's use f string here. um, args and change of line, and uh, config.args, and then change of line, and then what else? Hips and change of line. Oops. Config dot hips. Okay, and here's how we will build the perfect. Right now, let me just do this again, and no attribute build config. Okay, it's get config, right? Right. So you see, we get the args. These are the args, and these are the hips, right? Great, perfect. Now let's try to run a trainer function for two epochs. Let's see here, two epochs with batch size 16. So what do I do here? I will essentially use the same command, and then anything that I want to override. So I want to override args.epochs to 2, then args.batch size to 16. Okay, it's already 16. And maybe I want to seed my experiment with 0. Right. Let's see. Now our args has changed. So this file doesn't change, right? This is the really the very core of the idea of that what I'm trying to explain here. I have one central truth of the hyperparameters, one place where you have this uh, values that are not being edited. This is the default, and you can use these values and you can override them using the programmatic Python commands or through command line without getting into the parse complexity, and then it really bloats the code too much, right? So here I have simply changed the experiment configuration. Now if the config has been changed, essentially the model.fit will get these arguments and it will change my entire training structure. Now this can again be done in a programmatic fashion also. So for example, uh, we again, this, if we don't pass anything, this function will get the default parameters, right? What we can now do is, instead of doing this a command line way, let's look at an example of doing this in a Pythonic way. Let's say someone is using your API. Now it comes to that, right? So we had this previous version where we checked for is instance. Okay, let me just copy this. This is much better. So if the get config can now accept a file also, so it can accept a default hyperparameter. Now we should already have this by now. So the default hyperparameter will be this file. So let's say defaults.yaml, and essentially this will go here. Okay, and it can be uh, from typing import union, just by its name, and from pathlib import path. Okay, perfect. Now it can either accept the dictionary that as we were passing the omega conf predict, or it will accept the file name which will just load. So now here it will see if this is the, and again we change this to args and not it's okay, and it will check if it is a string or a path. Then it will load the config and then try to return it. Otherwise it will just return it. And the thing is we should still have the same result, right? So let me just quickly use, okay, I should have been careful, but config.args, okay, shit. My struggle here is really embarrassing. And this too. Yes, it's solid 20 seconds probably. And then what we have next is hips. And we have config.hips. Great. Let's run this. This should still work fine. I think, yeah, it does. Now let us say that you're using this programmatically. So instead of doing this, let me just comment this out, or maybe it should be like train. Okay, never mind, never mind. We don't want this, or maybe we can just it's none. And now here, as an API, we define this, and we don't really pass anything because we know that it will get, we want to use a default, hyperparameters. Now here in trainer, let's call it trainer, I can programmatically edit things like args epochs equal two, and then trainer dot args dot batch size equals 8. I can also edit hyperparameters. Trainer dot hips dot lr0 is 0.1. This is also perfectly valid. So if I do this, and let's say I print the same thing here, let's see what happens. So just want trainer.config, trainer.config.hips. Okay. Now let's run this function and let's see the difference. Okay, the source. Which line? Let me see. This one here, default YAML. I'm pretty sure this should work. Let me see. Probably I'm making some weird mistake here. Maybe this. Open source Hydra defaults.yaml. Okay, it's default, not defaults. Okay. It has no object config. Sorry, I should have just print trainer.args and trainer.hips. Okay, here's the real deal. So by default, it got initialized through the same file to trainer epochs, batch size 16, and LR0 is 0.001. Now after that, we edited that epochs, batch size, and LR 2.01. This is the real power of Hydra. So now we don't have any complex workflows or really bloated code files where you have to provide two ways of entry into this default YAML or into these parameters editing game. So it can be overridden by multiple sources, and these can be uh, these don't require any extra or special treatment, right? And this file also will not be changed. Now, Hydra also does one thing. It produces a directory called outputs with the, the parameters that are passed through command line or whatever parameters are passed. I have done this to disable the directory creation because I don't want it, but I can show you this quickly, going back to our like command line way of doing things, um, how it can be done. So let me just pass it my CFG. Oops. Right, and okay, so it should create an outputs folder. Great, and then here we will have. Let me run one more to create multiple folders. Now you have like the timestamp. So first is the date, and then you have the timestamp, and these timestamps will contain Hydra. This is the config that it started with, and then this is sort of the Hydra template commands, which probably will be used to can be used to debug things. It's like a debug log, and then overrides.yaml is like how many arguments have you passed to this to override this, right? This is another thing. Depending on how many people in your team are, how many what is the level of reproducibility you want and management you want, you can enable this or disable this. It was too verbose for me, so I'll usually disable it, but then it depends on your workflow. But the great thing that I want to focus here is that this is just the beginning of what Hydra can do. Hydra is really amazing. So you can, this is just the starting, right? You can compose things, you can use data classes, you can use multi-run, things like that. It's really amazing. And I think if there is a way, so essentially you can over engineer anything, even Hydra. It's a great tool, but it can, if you try to sort of solve every problem before it even starts, you can over engineer it. In traditional computer science, sometimes it's called premature optimization. It's not nowhere close to that what we're discussing here, but it's a really powerful tool. But if you sort of don't use it carefully, it's like, every time you find a config, you create a new config file and then build hierarchies. It will end up becoming more complex than the problem it was intended to solve. So which is why I like to keep it simple, and this is the simplest example. There's a central list of defaults which can be edited through any means without creating special interface for those inputs. So this is the pretty much the starting point of Hydra, uh, and this is probably, it's the 80-20% rule, right? So 80% of the users, probably 90% of the users will use like these 20% features. So uh, I don't know. I think this really is useful. I think any this solution is probably the best default solution for managing experiment configuration instead of using Yaks or YAML files only, or data classes only, because this provides both the command line and Pythonic interface. So yeah, probably it has been like half an hour. I don't make such large videos, but yeah, it was really amazing experience that I had using Hydra. So I thought maybe I should probably make a longer one. I did not intend it to be this long, but hey, what can you do? So yeah, that's it. I'm not gonna take much more time. So yeah, that's Hydra. See you next time with something else.